Thank you for the opportunity that has been given to me. I'm Ruth Yolanda, Karvisa Raja. With me are also Mrs. Farsina Fahma and Mr. Eko Pujianto from Industrial Engineering, 11 Maret University. And I, as a representative of the research team, will present our research entitled Implementation of Lean Six Sigma Reducing Downtime Waste and Proposed Improvement of Flooring Board Production at PTLBB. The background on which this research is based is exports are crucial to support economy during COVID-19 pandemic. And PTLBB as an industry that produces and export flooring board has quality problem where there's a downtime, as you can see, 9 ways that will be solved using Lean Six Sigma method. This is the sample of the data. PTLBB needs to carry out continuous improvement in the quality of its production process. The implementation of lean manufacturing is crucial in the waste reduction procedure. The Six Sigma consists of 5 processes: define, measure, analyze, improve, and control. But in this study, only up to the improvement stage. And then the methodology. First, researcher conducting initial identification and then implement DMIE method. In define stage, identification of waste, we identify the physical and information flow using PCM, looking for the relationship between waste and measure stage, determination and calculation of CTK, number of CTK, calculating sigma score, selecting critical waste with a prioritized matrix. In analyze stage, we look for root cause using fishbone diagram and failure model and effect analysis of FMEA. And then improve stage, development of improvement alternative based on FMEA results and making selected improvement alternative to improve the quality of production process. And the last, conducting a trial and analyzing the result for improvement suggestion. Result and discussion. At define stage, the result, total cycle time without inventory is 1495.17 hours, while the value added time is 1206.11 hours. The PCA of this line is 79.4%. That means that there's still 24.6% non-value added time, so that it can be categorized as a high enough time waste. After that, it was also found that there are interconnected ways. We found defect directly affect overproduction and inventory, and also indirectly affect environmental health and safety, motion, and transportation. So, defect needs more attention. The next stage is measure. And the result of the determination and calculation of CDK, as shown in the following table. Total CTK will be used to calculate sigma score, and you can see the sigma score for each waste. And then we can see the waste that has the highest total project priority score when we using prioritized metric is defect. Defect waste has a direct relationship with product, has a quite low sigma score, 3.4, easy to solve and have a high financial impact, as we can see in the following slide. The next stage is analyze, where we look for root cause of defect. There are 4 types of defect: revision, downgrade, redry, and reject. We analyze each of type of defect using fishbone diagram, and then we analyze it, the risks of each root cause using FMEA. The types of downgrade and reject defect have the highest risk priority number, as you can see. And then After finding the root cause, improvement is made to prevent defect with Pokayoke method, which increase the reliability of the quality control process. But defect detection equipment is still very expensive. For example, you can see Venic Easy Scan with a price range of around 300,000 to 500,000 euros or 3 to 5 billion rupiah. For this reason, an alternative improvement is proposed by designing a simple wood defect detection tool that is easy and inexpensive to make. For hardware, we use Arduino Nano and then GY31 TCS3200 color sensor, ultra-tight sensor, OLED LCD breadboard jumper, momentary push button, mini USB, and the software we use Arduino IDE and some library. And we can see how the tool works in this diagram. When the tool is on, we can see in this picture, the sensor automatically detect object. We can see the color, composition, and the distance. And then wood that doesn't have not the good one is broke near to the sensor, and we can get a set point. Uh, the object distance in the sensor is 2 cm and can be changed in the program. Then the surface detected by the sensor is about 25 until 30 quadrat centimeter. After determining the set point, if the next wood has knot or bore, it will be detected as belang or skein or bolong or hole. Improve, and then trial result of 40 wood samples, which was taken randomly. You can see the result for the sample, and we can see 10 samples not detect correctly. So the effectiveness of detection is 75%. This is caused by the sensor not being able to detect colors that than constant or hole or scratch that have a small diameter. Suggestions for development for further research: use camera sensor, replace with a sensor which has a larger and wider detection capacity, improve the program to speed up the detection time, add audio output, and then you can see the advantages and disadvantages of the tool. This tool is simple and easy to make. This tool with affordable cost for small and medium industry, small size, can be placed with other machine. Very small electrical power doesn't increase production cost significantly. And then by integrating this tool with QC officer, the quality control system can be improved. And the disadvantage of this tool is the accuracy, and then it requires good conditioning, and then the detection speed takes a long time. And the tool is more accurate for lighter wood, but not the darker one. The wood surface area or capacity is also limit, which is 30 quadrat centimeter. Conclusion: 9 ways or E-DOWNTIME ways have been identified in PTLBP with the sigma score. The sigma score. After that, we found defect is the most critical ways, especially downgrade and reject defect types. And then we made a simple defect detection tool using Arduino Nano, etc. After testing, it was found that the simple tool was able to correctly detect 75% of the sample. The tool is still limited in the duration, capacity, and accuracy. This simple defect detection tool is open for further development. That's all my presentation. I apologize if there are shortcoming in my research or my presentation. Thank you.